Hello friends, today we'll be looking at the 8th chapter, which is about performing iterative processings. Okay, here we'll be looking at like the do groups, the sum statement, the iterative do loop, and the do while, the do until statements, the leave and the continue statements. Okay, so let's start off. So many programming tasks require that the block of codes to be run more than once, and SAS provides several ways to accomplish this with the do groups, then the do loops, the do while statements, and the do until statements. So let's start off with the do group. Now to demonstrate a do group, what I'll do is I'll start off with a data file containing some information of students, which is regarding their age, the gender, the midterm grade, the quiz grade, and the final exam grade. So this is the file, which is grades, and it's located in the learning folder. We'll start off using this. Now you wanted to read values from this file and compute two new variables, that's the age group and a value which is relating to the grade. Okay, all this is computed from the midterm and the final exam grades. If the age is less than or equal to 39, you want to set the age group equal to younger group and the grade to be computed as a weighted average of the midterm grade, and the final exam grade is will be calculated accordingly. Now if the age is greater than 39, you want the age group to be the older group and computed as a simple average of the midterm and the final exam grades. Okay, so this is the condition. So we'll go ahead and write the codes. Data, grades, length, gender, $1, quiz, $2, then the age group, $13, and we'll give the in file statement to locate where is the data source. I'll go ahead to my learning folder, which is in my C drive. So C learning / grades .txt, and we'll give the miss over. So any values which is missed will be encountered. Then we'll input the variables, that's age, gender, midterm, quiz, and final exam. Now if age is missing, then we'll give if missing age, then make it carefully, then delete. Okay, then delete. Otherwise, if age less than equal to 39, then age group equal to younger group, as I've mentioned earlier in the condition. Okay, now if age is less than 39, then we'll give the grade equal to, which is 40% of the midterm, plus 60% of the final term. Then I will give the other condition, that is if age greater than 39, then the age group equal to older group and copy this. Grade will be simply midterm plus final exam, so average by 2. Correct? And we'll run this. Let's go to the libraries and the work folder. So let's see. Okay, you have the age group and the grade being calculated. Okay, so I'll explain you the program. How does it happen? One thing let's do is let's take a proc print of it. Okay, so we'll give the title and we'll give listing of grades. We'll give proc print data equal to grades and no OBS, and run it. Okay, in this way it would be a little in front of our eyes when I'll be explaining you what it happened. Now notice that the first two if statement, okay, here and this, the first two if statement and the last two if statement, sorry, this and this, okay. Now the thing is, you'd like to be able to test a condition and then perform several operations. By using do and end statement you can do this, and it would be also quite easier if you use a do and end statement instead of writing so many ifs. I'll show you how it is done. Copy the same stuff from this. Okay. Now after this, if age is less than equal to 39, then do age group equal to older, age group equal to younger group, okay, close this, and grade equal to the same computation in grade. I'll just copy that, and we'll end this here. Then we'll write the else. If age greater than 39, then do just copy this and I'll change it. Instead of younger group, we'll have it as older group, and this would become the average of the both exams. We'll end it and we'll run it. Yes. Let's run it. Okay, so the same stuff, everything is the same. That logic is little different using the statement. And if you take out the print also, it's in the same manner. Let's take out the print. You see, the output result is the same as in the first condition. So you see the do loop, it makes the program much more efficient. Okay, so all the statement between the do and the end from the do group, from the do to the end, so this becomes your do group. Now when the if condition is true, all the statement in the do group they execute. Now a good way to think of the structure is, if the condition is true, do the following statement until you reach the end. It's a standard practice to indent all the statement in the do group as I have shown in the program. Okay, now you should take note that both of these programs work properly if there is a missing value for age also. The missing function returns a true value if its argument is missing a character or a numeric value, and the delete statement does two things. First, it prevents the current observation from being added to the dataset. Then second, it forces a return to the top of the data step. Okay. So let's now check the next statement, which is the sum statement. Now the programs in the next few sections that I'll be showing you, all this, they make use of the sum statement. Now this seemingly, it's a very simple statement, but it is extremely useful, and you may find yourself to use it in majority of your SAS programs. Yet many of the programmers who use it don't fully appreciate how it works. There are two primary uses of a sum statement. One is to accumulate totals such as month to date total, and another is to create a counter, a variable that is incremented by a fixed amount on each iteration of a data step. Now suppose you have a data set with one observation for each day of the week, and you want a program that will read in these values and compute a cumulative sum. And we'll see a program that creates a test dataset, suppose revenue, and it attempts to create the cumulative sum. Okay, suppose we'll say data revenue input day equal to $3 dot, and we'll say revenue as $6 dot, and look at total equal to total plus revenue format revenue total and $8 dot format. Okay, and we'll give the data lines. Data lines, give Monday $1,000, Tuesday $1,500, Wednesday suppose nothing, Thursday suppose 2,000, Friday 3000. Okay, let's run the program and let's see what's the output. Okay, so let's see the file revenue. Now you see Monday revenue, the total is nil here. I didn't compute. Tuesday nil here. Wednesday it's missing, so nil here. So when you see this program, remember that the variables read from the raw data or created by an assignment or statement are initialized to a missing value for each iteration of the data step. On the first iteration of the data step, you are adding a missing value to the total, to a revenue value of suppose $1,000, and the result is a missing value. So using the same logic, if you see that the total is missing for each and every observation, okay, now you can use a return statement to tell SAS not to do this. Sorry, spell it as return. It's retain statement. Now the retain statement also enables you to set a initial value for a variable. Okay, so we will repeat this program and we'll use the return statement in here. Okay, close this. I'll just copy this and I'll show how this program is modified. So after data revenue, what you need to do is add a statement that is retain total 0, and let's see, let's run the program. Now you see here the revenue and the total has come this side. It has to come that at the end. So you see the total. Okay, now everything works fine until the program encounters a missing value in the revenue here. Okay, now this sets the total to a missing value again, now where it remains for the rest of the data system. You can fix this by adding a statement to test the value of the revenue before it attempts to add it to the cumulative total. Okay, and how will do that? I'll just copy and modify the program to show you. So this is the statement. Instead of total is equal to total, before that we have to use if not missing revenue then total is equal to total plus revenue. Now let's compute this, run this. Okay, and see. So first you see this, everything is being added. Okay, even the condition where the revenue is missing So what happened exactly? Now this time the program worked correctly, but there is an easy way to use a sum statement. A sum statement takes always the form of like variable plus increment. Now notice there is a plus sign and no if here there is, we have given a equal to sign, but instead we can simply give a variable plus increment, okay, like this. Suppose variable plus increment, okay, and here there would be no equal to sign. Now this statement does the following: one is variable is retained, the next variable is initialized to 0, the next the missing values of the increment are ignored, okay. So if you rewrite the program, then what we should do here is, instead of this whole if missing, then you need to just take out this, and this also won't be needed. Just then run it. Let's take it out. Now check. You got all the totaling absolutely correct, right? So another very common use of the sum statement is to create counters, okay. Now for example, if I'll give something like data test, and I'll give input x, and if missing x, then miss counter plus 1, okay, and we'll give the data lines, the data lines suppose 2 dot 2 dot 7 dot 7 dot, okay, let's give this much only, and let's check the output. Check the test, okay. So what happened? If you see, the miss counter is counting the numbers of the missing value for x. Here the miss counter is 0, here the miss counter is 1, here the miss counter is 1. When the next missing value appears, the miss counters turn to 2. So this is how you use the sum, okay, to keep a counter. Now let's see the iterative do loop. How does that work? Now, although it's very useful to have the capability of executing a group of code when a condition is true, but there are times when you would like to execute a group of statement, SAS statement multiple times, okay. So we'll go ahead and I'll show you how this what are the conditions and okay. Now suppose data compound, yep, data compound, and 375 and total equal to 100. We'll give then year +1. So just we are checking out a program without a iterative loop. How does tedious it is. Okay, now I'll give a total plus interest, DEREST, interest into total, then output. Okay, so I'll explain it why I'm doing this. Then let's give the format total $10.2 will run it and will print it. That is title listing of compound and proc print data equal to compound with no OBS and run it. Okay, let's first run this. Okay, then take out this. So now you see, now the purpose of this program is obvious. You want to compute the total amount of money you'll be having if you start with $1,000 and invest it in a invest at something like a 3.75% interest rate for 3 years. Okay, and absolutely the program works fine. For 3 years we computed it. Okay, now as I discussed, the statement year +1 is a sum statement. It increments the value of year by each one each time it executes. Now the value of the total is also computed using a sum statement. Notice here that the increment can be an expression which is interest into total. Okay, and if you see the output statement also, there's you give the instruction to the SAS to write the observation, and the output usually occurs automatically at the bottom of the data step. Okay, but here you want the output and observation each time you compute a new total. So when you include an output statement anywhere in a data step, SAS does not execute an automatic output at the bottom of the data step. Okay, so next you notice that there are there are 3 group of statement. Okay, now starting with this, the sum statement is repeated 3 times. This is a clue probably that we can do this program in a better way using the do loop. Okay, so in the next program we'll use the do loop to achieve what we did earlier in this program. We'll get data compound and write interest equal to 0.0375 total equal to 100, do year equal to 1 to 3, and total equal to total plus interest plus multiplied with the total, and here we'll use output and we'll end it. We need to format the total as dollars, so total dollar, we'll give the 10.2 and we'll run the program. So let's run it. So see, when this program executes, you see the year is first set to 1, okay, and the lower limit in the iterative do loop, okay, the lower limit in this iterative do it's set to 1 in this lower limit, okay, of the do range. Now all the statement up to this end statement are executed and the year is incremented by 1, which is the default increment value. SAS then sets it to the new value of the year, okay, which is in between the lower and the upper limit, and the value after the keyword to, okay, here. Now if it is that the statement in the do group executes again, and if not, the program continues at the first line following the end statement. So when we execute it, we see it, the data set is generated, or maybe we'll just rerun this to have a list output, okay, here. So the interest in the first year and the total, interest of the second years and the total, interest of the third year and the total, okay. So this one here, I'll just clear it off, okay. So next we'll see that like suppose you want to generate a table of integers from 1 to 10, okay, along with their squares and the square roots. Most of the simple program that we did it with C or C++, okay. So how we do that with an iterative do loop, okay, in SAS. Suppose data table, say do n equal to 1 2 applications, run it. So let's first go ahead and run the data step. So done. Where is it? Table is created. Okay, now let's run the print statement. So there you see the table of squares and the square root is created from 1 to 10. When n is equal to 1, the square 1, the square root is 1. When n is equal to 2, the square is 4, the square root is 1.141. Okay, so you notice that this program does not have any input data. Okay, and it generates the value of n in the do loop, and it computes the squares and the square roots. Okay, and the sqrt which I have given. Okay, the sqrt is a square root function. Okay, it returns the square root of its argument, that's n. Okay, and if you see the output, it's an observation to the data set. Okay, now this continues for all the values from 1 to 10. Okay, here in the output. No, so what happens? Suppose, okay, what if you want a table where n has value of 0, 10, 20 and 30 and so forth up to 100. So how you'll be giving the do statement then? The idea is simple, as we learned in the other programming techniques. Do n equal to 0 to 100 by 10. And suppose the do loop can also count backwards. Suppose like the values like 10, 8, 6, 4 and 2. How do we do that? Suppose like we'll give a do index equal to 10 to 1 by minus 2. So the common techniques we used to use in our programming language, the logic remains the same. So let's see another example wherein you have an equation relating x and y, and you want a graph of x versus y, y versus x for the values of x from minus 10 to plus 10. Okay, so I'll repeat that. We'll be doing an example wherein you have an equation which is relating to x and y, and you want a graph of y versus x for all the values of x from minus 10 to plus 10. So we'll have a data equation have do x equal to minus 10 to 10 by 0.01 and y equal to suppose 2 to the power 2 into x to the power 3 and minus we'll have 5x, no, 5 into x, 5 into x up, and minus, we'll keep it as 8. Okay, so this is the equation, that is 2x cube minus 5x minus 8 Okay, so this is the equation, and we'll have the output. We'll end the do, and we'll add the run statement. Now for the print of the graph, what I'll do is start using symbol sim, symbol value equal to none, and we'll use interpol, that is the interpolation is equal to sm, and width equal to 2. We'll use the title as, so we'll give the title as plot of y versus x, and use the proc gplot data. In my coming classes I'll be explaining you about the gplot and all. Okay, equation plot y versus x, and we'll run it. So let's run the program. Okay, and if you want to see the data set, let's see equation data set. Okay, so starts from -10 and it goes all up to the way of to +10. Okay, and let's generate the graph. So you see the x starting from -10 and continuing up to +10. Okay, and the values been plotted. Okay, we'll minimize this. Okay, so let's go through the program what we did. So now the do loop starts at x is equal to -10 and increments by the value of 0.1, and it reaches till +10. Now the output statement inside the loop, it writes the observation out to the data set for each of the iterations in the loop. Okay, and when we run the program, we got the plot, which is y versus x. Okay, so let's check out some other forms of an iterative do loop. I'll close this. Okay, and now you can also provide a list of numeric or character values, okay, from the index variable. Okay, following the following the index variable. Now some of these examples, like if you can give like do x equal to 1, 2, 3, 4, and or give something like, just a sec, you can give something like let's put the do x equal to do not x, do month equal to Jan, comma Feb, comma March. Like this also you can give. Then you can give like do n equal to 1, 3, 5 to 9, and you can give a by 2, and you can give also extending that not 2, we can give it like 100 to 200 by 5, you can give it not maybe by 50 you can give it. And so here in this you see the value of n are like 1, 3, 5, 7, 9, 100, 150 and 200. Okay, in this, suppose and if you use the character value in the do statement, the length of the first character value determines the storage length of the index variable. Therefore you need to use a length statement to set the storage length of the index variable. Now using the character values for the do loop, indices can be especially useful. So you, like for example, now you have 5 scores for a patient on a drug, and you have 5 scores for the patient on an active drug. Okay, maybe a passive drug and an active drug. Now the raw data values can be arranged like this format, like 250, 222, 230, 210, 199, and suppose 166, 183, 123 and 129. Okay, 129 and 234. So suppose these are the kind of data lines you will be having. Okay, raw data lines. So, and if you want to read, okay, using a do, how will do that? I'll show you. Suppose data, I'll name is as easy way. Okay, let's say data easy way, and suppose do group equal to placebo, placebo and one as active. Okay, and do subject equal to 1 to 5, and we'll give input scores score at the rate, and output this input statement here. This is referred to as a single trailing at sign. Okay, and this stuff we'll be discussing in my chapter 21. Okay, wherein we'll be looking at different advanced inputs. Okay, so okay, and if you see, to keep this program compact, now it was convenient to place all the scores in a single line without the at sign. Each time SAS executes an input statement, it goes to a new line, okay, of the data. Now the single trailing at sign in an instruction, okay, at sign, it instructs to hold the line for another input statement in the data step. Okay, so that is how things change if you use the at sign, okay, with the input. Now let's look at the do while and the do until statement. Instead of choosing a stopping value for an iterative do loop, you can stop a loop when a condition is met or while a condition is true. So enter the do until, in this case it helps. So now we'll be looking at the old program what we did of the compound interest problem that we took on, okay, earlier this. Okay, so I'll take you to that program. Here it is. Now if you see, instead of asking how much of money you have after X years, you want to know how many years you need to keep your suppose $1,000 in a bank at 3.75 interest to double your money. Okay, so instead of the target is suppose $1,000 or $100, and we need to find out that how many years we need to keep it. So write the program. Data suppose double and interest equal to 0.0375. Total equal to 100, and do until total greater than 200, and here +1, and total equal to total plus interest into total output will end it will then format total $10.2 and before running we should add the titles and take a print of it. Let's take the title and so we'll add the titles like listing of table and so listing of table and prop print equal to prop print data equal to double and no ops and we'll be running it. Let's run this. So there we have the double. We'll take it in the print format. So here you see so from $100 you have invested, suppose at the interest of 0.375, and how much year it takes to reach or to cross 200. Okay, it takes 19 years. So the condition is placed in parenthesis, you see, total G greater than 200. Okay, so in this example the loop continues to repeat until the value of total is greater than or equal to 200 is reached. Okay, so an important point also you should remember about the do until is that the condition placed in the parentheses after the keyword until is tested at the bottom of the loop. Therefore a do until loop always executes at least once. Okay, so let's look at a do while. So the alternative to do until is the do while. Now as you might expect that a do while loop iterates as long as the condition following a while is true. There is another difference between the do while and the do until. The while condition is tested at the top of the loop rather than at the bottom. So unlike the do until block that always iterates at least once, a do while blocks and does not execute even once if the condition is false. So if you rewrite this program with the do while, so let's see, we'll give a data table and we'll keep the same total and the interest. Okay, and we'll give a do while and total LE less than 200. Now year +1 will have total equal to total plus interest into total, and output and Okay, now the block of code between the do while and the end statement executes as long as the total is less than or equal to 200. Okay, now yeah, there is a, you have to be little cautious when when you use a do until statement. And why it is? Because it's very important that the condition that you place on a do until statement becomes true at some point. For example, if you change the do until statement, okay, in the given program, okay, here, now to read the following, the condition is never true until you have you have what is called as the infinite loop, the do until. Suppose total equals to 200. Now, depending on whether you are not or you are playing for your computer time, this could be a bad or expensive thing. Now, on a platform, you can usually interrupt the program by selecting the icon, stop a SAS program now, or the control C. Okay, so the lesson here is to be very careful, okay, when we are using a do until statement. Make sure the condition that you specify eventually returns a true value, which is very important. Okay, the one way you can prevent an infinite loop is to combine a regular do loop with an until condition. Okay, and it's easy. Suppose here same will take and here we'll mention do year equal to 1 to 100 until total is greater than 200. Okay, and you give the total plus interest total equal to total plus interest and into total. We'll write the output and we'll end it. We'll add a format, total $10.2, and we'll run it. Okay, now it's the same logic. What you are trying to do is stopping the condition and you're ensuring that the necessary true condition is supplied. So there are two advantages to this structure. First, even if the until condition never becomes true, the loop ends. Now when year reaches 100 and second, you don't have to assign a value to the year inside the loop. Okay, so it stops. Okay, now we'll see the another two statements, that is the leave and continue. Now the leave statement inside a do loop shifts the control to the statement following the end statement at the bottom of the loop. Now the continue statement halts further the statement within the do loop from executing and continue iterations of the loop. So how does that happen? I'll show you with an example. Suppose data, we'll name it as leave it, and interest equal to 0. I should give this 0375, and total equal to 100. Do year equal to 1 to 100. Then we'll give the total equal to total plus interest into total, and as we'll give the output. And here, if total greater than equal to 200, then leave. We'll end it. We'll provide the format. I think I should go ahead and copy this and paste it. Yeah. And run it. So the same output, but where is the difference? Now in this program, if you see, the loop continues until the total is greater than or equal to 200. At this point, the leave statement terminates the loop. Okay. Now to demonstrate a continue statement with the same, we'll data continue on. We'll say take this okay 1 to 100, and here we'll give until total greater than equal to 200, and we'll specify the same total, and we'll give if total equal total less than equal to 150, then continue. Right, and we'll get the output, and we'll end it, and we'll format the total. So let's execute this. So continue on. So you see, now as long as the total is less than or equal to 150, the continue statement causes execution to drop to the bottom of the loop, now skipping out the output statement. Okay, here. Now, and as the loop continues, now when the total is greater than 150, the output occurs, as you have seen here. Okay, so and the outer loop continues until the total is greater than 200. So you see that this program, it prints the value of the total which is greater than 150 and until the total reaches or exceeds 200, right? So that's all in this chapter. We'll just check out in the next chapter. Thank you.